Okay, before the break, we were looking at writing data to a sequential file as far as data storage purposes. Using that payroll example we've been using in class to store our employee names and rates of pay. And we just wrote it to a sequential text file, means everything goes in order. But that's not the only type of file that we can write them to. So let me jot down some more notes, which I guess I did share screen over here. Share screen and share screen number 4. Okay, yeah. So I'm not sure. I've got to figure out what the best way to use this new tool is. I don't know if it's going to be this, but I can see one big advantage is when the night's over, I can hit just download it as a PDF and add that to the stuff on GitHub. Grab my remote and point the camera over here where I'm going to be standing at. So that could be useful. I've got to get used to practice writing here. I have awful handwriting. You all have probably noticed by now. I'm one of those people that sometimes have trouble reading my own handwriting. But I'll figure out how to use the new tool. It can be useful. Sequential files aren't our only option. That's only one our book covers, but there are a couple other options. The next one I want to look at is comma separated. Maybe I just need practice up here with this stylus, because that already looks neater than it did the first time. Comma separated value. Oops, that's not value. Let me try that again. Comma separated variable is the name of the file. A CSV file. And these are exceptionally nice. Spreadsheets grew out of CSV files. So all those rows and columns you're probably familiar with from spreadsheet, that grew from CSV. So think of rows and columns like a big table. So instead of coming up with a sequence like here, we had to remember on that last one before the break, we had to remember the even indexes have the name and the odd indexes have the rate of pay. But with a comma separated variable, each record or thing we're representing, each line has related, I'll say connected. Related would be a better word, but I don't want to use related here. Each line has connected data points. Yeah, I think I mostly just need practice typing with the stylus. One definite advantage is the whiteboard doesn't have a download as PDF button. It's definitely not as much room here either. Has connected data points, delimited. That's our technical term. Delimited, or in parentheses, I'll put separated, because that's what we would say in normal English. Separated by a special character. So by default, the special character is obviously going to be a comma. That's what it's named after. But a comma is something that's often going to show up in our data points as well. So that adds an extra step we have to put in there, extra things to keep track of. But we have control over that. And we could just do it like a sequential text file, write our data point, write a comma, concatenate on another data point, concatenate on a comma. Not hard at all. There's a library built in that makes it a whole lot easier. So let's look at the library for it. Oh, not that folder. Let's try it. Fall 2020. Like this one. Nope, that's not the one I'm looking for. I want to copy from examples so I don't get carried away. Spring 2022, did I do it there? Nope. Chris swore it was fall 2021. I teach the SDEV one, I've got the SDEV 140 class a lot of assignments, general notes, nope, gonna be in there. Where's the example I want to look at? Well, I'll go to another class. I know I showed it in the Python class last spring. Here, oh, that's a mess. Sorry, I should have pulled this up on the break. Well, I know the library, so I was going with the library, or maybe trying to keep doing this. But we put all of our stuff in one row, separate it by commas or some other symbol that makes sense for the particular situation. And then we read it back in one row at a time. There's a library that's built in that we can use to work with. So I want to do it that way. That's why I was wanting to pull up the example, because if I just do it all off the top of my head, I might get carried away. Somewhere in here, I have an example of this from an SDEV 140 class. There's absolutely nothing in that folder. So fall 2020, then found it again in spring 2021. It's here. Nothing in that folder. A little disorganized sometimes. Fall 2021. This class is one that runs a lot, so I've tried it quite a few times. Oh, here we go. The file example parent, it's even organized. What folder was that in? Fall 2021. Okay, I gotta try to remember that. That's what the organized version is. So instead of a sequential file, we want to put all of the related data. So in our case, there's only two data points, right? Name and rate of pay. We will put those in the same line, separate them with a comma. That would be an easy thing to write, but I want to show the library because not all of our stuff is going to be that easy to write, right? Probably going to have more complex situations. Close this. Oh, and all those changes work, so we can remove those comments now. Just keep that in mind. You always want to be able to get back to the last thing that did work. So comment it out, make the change, and then wait until you know for certain that it works before you delete it. All that stuff can go. Just don't need so many empty lines here. Whoops. I'm gonna get rid of the empty lines. There we go. Clean that up a little bit. And this is the sequential file version. And this is another thing that will often show up in software development. There's more than one way we can do anything. So something that we often do is do alternate versions. So here's one with the sequential files. I'm gonna come up here and go save as, get a copy here, and 311 will be the one, we'll change this one up to use CSV files instead of sequential files. And for that, there's a library we can use. So I'm going to import CSV library. I guess we'll write it first. So here we're opening a file. And that we'll do the same way. So like employee, I'll call it employee comma so we can keep track of it, but change that extension so instead of text, it's a .csv file. I'll still keep it for a pin. That way we don't have to start over every time that we're gonna add more things. Is there another employee? Yes, that'll be the same. Those prompts are starting to get rude. They don't look like a cheerleader prompt anymore. It just looks like somebody at the computer program is very, very angry at us. So we'll probably want to clean those up at some point, but that can wait till later. We know what the prompts are for while we're debugging it. And here's what's going to be different. Instead of writing it, we'll open it up. And when we get this, we really want to we have to write it as an array. So instead of multiple lines to write that data, I'm gonna take that out. And this is what changes because we can use that library and create a special kind of writer, which I'm just gonna call it writer, is that CSV module has a .writer object in it. We want to use that, and then we give that our file handler. And then we can use this to write our files, specific CSV files, because we write them a row at a time. So we'll have write row, because we have everything for this row, the name and the rate of pay. And when I open parentheses, notice that what we have to pass in here, our parameter, it needs an iterable. So it needs an array. So we could have just created a new array here, but like I was saying earlier, you always want to minimize scope. So I'm just going to make a very temporary array just in this one line. So I won't even store it anywhere. I'll put square brackets, and because normally that's what we would do for an array, right? So like employee equals square brackets, and then we put name and rate of pay in there. So it might make more sense to you to do it that way and then pass in employee down here. But I'm just going to take this part and pass that in, because that's the only place we need it right here. So we don't really need to store it. Why doesn't it like that? Oh, yes. There we go. So we'll write that. It doesn't hurt to have some labels. So why don't we add some labels to this? And I read it up here. So I'm going to have to change this to make some labels. So I'm going to cut this. Well, actually, no. I'm going to leave that there, write the row, and then that's all we'll need. And we'll come back and add labels, because right now we can see the two parts there very, very clearly. And to add labels, we would need to put the labels before the while loop, right? Because we only want one set of labels. We don't want labels everywhere. But also, we know what it is. We could skip the labels. And when we read the file, we'll do the same thing. It's now going to be called this. I'll paste that in, and it's a .csv file. We're still opening it as read. I'm sorry, what was that? And then once again, we can use that CSV module to create a reader object, which I'm just going to call reader, but the CSV module has a object called reader. And we pass in our file handler here. So the perm file. And then, excuse me, we'll read it in a little bit different, because every row is going to come in as an array. I want to do it here. Yeah, so I'm going to read that in. And the CSV file, all our stuff is organized by the line. So we don't have to worry about that line break at the end. The module knows that every CSV file has a line break at the end of the line, so it's gonna go ahead and get rid of that for us. So we don't have to worry about that anymore. Oh, whoops, I forgot an equal sign. The CSV reader is assigned a CSV.reader object. And that reader object just needs the file handler we created. Otherwise, everything's still very, very similar. I'm going to print this before we do anything with it. So print employee data. Or to just run read data. Let's add something in here. Now if choice is equal to 4, then we want to just read that because that's going to print it out. And before we start working with it, I want to print it out and look at what it is. I know what it is, but the general process is going to be to print it out and look at what it is before we start working with it, right? So we'll do that instead of just calling that directly. What did I call it? Oh, the names can change now. So instead of write sequential file, this is going to be write CSV file. And this one will be read CSV file. Sorry, didn't mean to zoom in. Want to be able to read the class examples, right? So write CSV file. And if they give it a 4, then we'll read CSV file. Which that part's just very, very temporary, so we can print it out and see what's there. So now if we run this, well, first thing, we need to add some data to that CSV. So number one, it's obvious at this point, is there another employee? Yes. I guess I'll use different ones. Again, not representing anybody, I'm just making these names up. So somebody named Mary, maybe this is a different company, they pay a lot more. So Mary makes $34 an hour. Is there another employee? Yes. Who is it? Kevin makes $31.31. And yeah, they make nice little symmetric wages. That works for classroom examples. Yes. And Mary, Kevin, and Michael. These do not represent anybody, just completely making names up. Maybe Michael makes $32.32. Oh, I guess one more. Yes. For a Kelly, who makes $33.33 an hour. So that'll be it for that. So should have written the file now. If we come over here, there's our employee comma file for the CSV, and you'll probably notice immediately what software that opens with. That makes a big difference. So just seeing what the icon for what software that opens with should let you know that's a much more organized way to write our files. So notice how each row has its own thing. And then the default library in Python adds an extra row, which is actually why I helped with print that separately, because we'll have to deal with that extra row at some point. When we read it back in, or we can remove it from the array somewhere, or skip an index when we read it back in. Lots of different ways to deal with that. Just remember that you will have a blank row every other way. And what is probably the most useful application of this, when we get to writing binary files, and we create an object, a binary file, it actually matches this form. It's just all binary code, but it will match this. So what I found to be incredibly useful over the years is if I know it's going to be stored in binary eventually, like a custom save for our own software, right? We're going to invent a .sdev file. So we're going to write our own, we're just going to save it in binary so it doesn't open with anything else. Nobody can just open the file and read it. It's not even readable. The binary will most closely match a CSV file. So while debugging, it's really, really useful to write to a CSV file so then you can see how your data is being stored and then pickle it into a binary file at the last minute. Which writing binary is really easy. Really, we just change the mode. So we like W is write mode. We would just set the mode to WB for write binary or RB for read binary. But then we need something to translate between the stuff that we actually put in our script and the actual one. But you can see there's a lot more organization here. Also, that output, the pay stub output would probably look a lot better in a spreadsheet than a text file. I'm gonna leave it there, but that would be my suggestion for this evening when there's a little bit of time at the end to look at stuff. See if you can download these files off GitHub or after class and see if you can switch the output on this CSV one to print that to a spreadsheet, because that's probably a more useful place to have the pay stubs. Otherwise, we would just have to copy and paste this stuff from the text file into a spreadsheet so we can do work with it in a business setting. I guess now I'll print that read one. So if I run it again and hit 4, just read it, notice we got an array, and our first element is a string that's kind of split by commas. Everything it read things back in with commas. So we want to split that up. This is actually jumping ahead to the array section, but we can quickly do that with just one word. Read CSV file. So when we read it, instead of cutting off that line break specifically, we can just say .split and split at a comma. Or we can do multiple things and split all of our data up at commas. And it looks like we also have some new lines there. So let's split this up at in quote marks. We'll put square brackets, and we'll actually put a regular expression in here. Regular expression is pattern matching. So this is the very first. The simplest pattern matching we can do is look at a list of symbols. So we just put them right in order. So like a comma and a \n go right in there. So now it'll split that array, and we'll get a different, notice it only brought, we'll get a different element in the array every time there's a or a new line. So that's something you're going to want to look at a lot. I believe our textbook mentions regular expressions briefly. It's pattern matching. You'll see it over and over again. And it can get large and complex. So let it build up over a couple of classes and just take it in little bitty pieces. So the first thing for regular expressions is if we need a list of symbols, we create a string, and inside that string is square brackets. And inside the square brackets are all the symbols we want to look for. And we don't need any separation, just put them right next to each other. Anything we would use to separate those symbols normally would be a comma, but like in this case, a comma is one of the symbols we want to look for. If you wanted to split on a space, you can either type space, or \s is the escape sequence for space. Some people like that one. I personally prefer that one because I can see that there. A space is something missing from the screen, but if I see the escape sequence for it, it's harder to overlook. But we're gonna check that, what we read back for all of those, both of those symbols. And when we do, we're gonna split that up into another array. And then we'll add it on to our thing. We also have extend, which would add an array to an array, but an append adds one thing at a time. And since we have 2 data points on each line, we want to add those 2 lines as a nested array. So it's keeping it as an array if we use append. You could also use extend and just have a big long array. Well, we'll see when we print it. Probably best just to see the output. So notice now we have our elements split up. So this first line has Mary, and then the data, and then that new line. The second one has just the new line. The third one has the name followed by the number, and then another new line. Actually, let's do just a couple. Let's see what variations we can have. I talked about regular expressions. At this level, be aware that regular expressions are something that exist. If we just split on commas, that looks a little bit better, because those new lines are in there, but we probably want to take those out. So I want to replace all of those new lines. And that's what line is a string. It's reading from a text file. It's in human readable form, so that is a text file, even if it has a different extension. And we have a string. So between having our string and splitting it up into an array, I want to remove all those backslashes, or all those line feeds. So notice how there's multiple method calls there. So strings have built-in methods. That's part of the lecture this week, which, as far as lecturing on it, would just be reading off the list that's in your textbook, and y'all can read the list in the textbook. There's 2 or 3 that we use a lot, and then the rest of them show up so randomly that we'll look them up every time we need them, because they're slightly different in every language. But we're going to take our string, and one of the things we can do is remove certain symbols. Let's go ahead and remove all the line feeds, and then we'll split that string up, and split turns it into an array, and we'll split on all the commas. Let's see what this gives us. Save from 4. Oh, string object has no attribute, probably removed, right? I'm thinking of replace is what I'm thinking of. I already remembered, but I'm gonna try. I was thinking of replace. Remove is a different language. That's something else you're learning. As you see more and more languages, they will blend together. I'll go to a tutorial this time. Programming has nice tutorials. Oh, this one's not like it. A lot of times, all of their examples will have multiple languages. So if it exists in more than one language, there'll be little tabs on all the examples, so you can view it in Python or Java or C++ and see the same tool in the different syntax. So Programming has some really nice tutorials for that. Replace, so we have the string dot replace. B with C, so our original string was bat ball, so we're going to replace all of the B's with a C. So instead of dot remove, dot replace the line feeds with an empty string, and that will just get rid of them. replace that character with emptiness. There we go. Now it looks like we have only the data we need in each particular thing. And now we can just go through and our array has removed. That was why I was the next line is what I wanted to do. Then I wanted to look and say if well, I'll do it afterwards. So now that we printed that out, we'll look through it again. So for employee and employee data, if employee is just an empty string, we can see that's what's happening right here, right? That one we don't need is just an empty string. Then we will remove it. Employee data dot remove employee. Oh. Yeah. And we want equal to, not assignment. See, little typos happen. Even years of practice, it's still, when you look at finished examples in textbooks and tutorials and stuff all the time, it probably throws you off seeing the nice polished off example and all, where you're constantly making typos and having to go back and forth. But you're only looking at the finished product. That they had to do a lot of back and forth to get that example going ready for the textbook. So that's just the process. We do not think like machines. We're humans. We are intelligent. We cannot force our minds to behave like we're a non-intelligent machine. We can get used to some things and get better at it, but there's always going to be that back and forth because we're human. We cannot wipe away our intelligence and think like a mindless machine. So we will always process a little bit different. We will always think differently than the machine processes. Or, oh, oh, I meant to print that again. And afterwards, print it again. Sorry, I forgot the trivial step at the end. There we go. Oh, it's still in there. So that one's a bit of a problem. Why didn't it remove that? Let's try this. For I in range for the length of employee data. So range of however long that is, if employee data index I is equal to empty string, then remove that index. Let's see if that works for us. Doesn't seem to want to remove those. They're still sticking around. Is this going to be different? It's using single quote marks. Let me see if that makes a difference. The normal debugging process. No. Here's the one beforehand. Here's the one afterwards. And those empty ones are still there. Huh? Yes, there's some stuff like that. I was going to switch to a different method. There's also pop, We have more than one way to do everything, so that doesn't remove it. What did I do in my example? I did put in an example so I wouldn't get carried away, and I think I'm starting to get carried away. Aren't I? Oh, in the example, I just ignored it. Okay, so let's do that because all of that stuff's probably confusing, right? It doesn't seem to be removing, but now we have it as an array, and some of them are just empty. So we either have two elements in the array or nothing. Actually, that might be a better check. Notice that saying it out loud worked better than just looking at that and trying to think about what it is. There's a popular method. Let me undo. Get back to this. We print it. So for employee in employee data, there's a popular method called rubber ducking. The idea is to grab a rubber duck and explain the problem to that inanimate object. And just hearing it will help you. It really does work. So try that. Next time you get stuck, try just saying it out loud. Explain it to an inanimate object. I always like to explain it to pets. So then it feels like I was just talking to space. Like if you have a dog or a cat around, tell your dog or cat what's wrong with the program. And oftentimes when you hear it out loud, the solution you'll realize what's wrong with your algorithm, actually hearing it. Things act different in our heads, right? We see it a lot writing essays, similar thing writing essays. We'll think we came up with a very clever sounding sentence, but then when we read that sentence out loud, it is not the same as it sounded in our heads. Coding's the same way. So instead of checking that, employee, this first element is an array with two things. The second element is an array with only one thing. So instead of looking for that empty string, it might be better to just remove that from our array. We can either say pop or remove. Those are both on there. So if employee, or the length of the particular one we're currently looking at is 1, then we want to get rid of it. I'll go with pop. Those relate to stacks and queues. We'll talk about those more later. Stacks, we pop things off a stack, and queues, like QUEUE, like a line, standing in line at McDonald's, the queue at McDonald's. We remove things from a queue. So we have both words relate to removing things. Let's see if that removed it for us. Oh, I guess it has to be an index here. Well, let me go back to the index one. I in range length of employee data, and this is probably what it seems like when you write your code, right? It's just lots and lots of back and forth. You do something you think is going to work, and it doesn't work, so we have to change it. If length of employee data I, the one we're currently looking at, is 1, then we want to remove that thing we're looking at. Is that the right syntax? What? Okay, I'm skipping this. That's getting over confusing. So let's just read it in and let's just ignore that thing. Whoops. let's go with the ignore method. Print employee data. Take it in small steps. That'll probably work much better. So number 4, print out what we have, and we'll just ignore that one if we get to it. I confused myself along the way there. So we know what it's printing out, so we take that out of the menu. Take that out of the choices. So then when we read it in, we'll look to see what is in there. So we'll look through the array, and every one of those arrays has an array. Every element in the array is another array. So nested arrays, we've seen that before. So we need a selection structure before we go and call these things. Actually, this will work. Actually, we're going up by 2. So we have index 0. We go up by 2. We'll skip right over index 1 and go to index 2. Skip right over index 3 and go to index 4. So that'll probably work better anyway. So we want index. Instead of separate lines, we have nested arrays. So we need a second index there. And we can see from the printout here that for that nested one, index 0 is the name, and index 1 is the data. Will that fit on there? I'm gonna have to zoom out. Oh, not that much. I'm gonna have to come way out there to see it. Oh, wrong way. Do you see how it's much more organized now? It's put into an array. It fits very, very nicely with this week's topic. That's what we want to look at is this week's, we're working with arrays, and that's a much more organized form to put our data in. And that took a lot longer than I thought it was going to. If I open that in Sublime, can we read it better? There's a lot of extra stuff going on here. Open with Sublime. Oops. So kind of drifted off for a second there. We'll get rid of that print line when we go back over there. But for every line in that CSV, we'll just remove all the line breaks and then split it on a comma. Does that make sense to everybody? See head nods here. Not really any feedback from the Zoom call. Hopefully that makes sense. And then down here, well, our loop was already increasing by 2. So that just automatically skips over all those extra lines. And that's a whole lot easier than all that other stuff I tried to do there, right? It's like, okay, I was seriously overcomplicating that for a moment there, trying to remove that thing. But this is a nice, simple, clean solution. We'll just ignore it. And then it really doesn't cause any problems at all and we know what is in the rows that we want. But really the big thing is it's more organized in our storage. Our program should behave the same. So I run this and ask for a weekly payroll. What are Mary's hours? Maybe Mary worked 34 hours. Oh, can only concatenates. Oh, so when we write that out, we do have nested arrays now. So name is index 0. But you all know this process. Try what you think is going to work, then type it out and see if it works. Kevin worked 35, 36, 37. So that all ran. Oh, this is probably going to add it right to that other file. We should probably make a secondary output. Oh, yeah. But it added it right to there and kind of made it look nice. So maybe we should send that to a different file. Looks like there's some formatting issues here. We could use another tab because that name's longer than some and push that over. There's different ways to make tables. We'll see some of those. So let me take that out of there. Oh. Or just ignore that. And since this is a different program altogether, I'll add underscore CSV on here. Oh, oops. Run that again and run weekly payroll. 33, 33, 33, 33. And now we have this other file where we got all that. All of our data is still saved, nice and organized still. Probably want to do something to deal with that name. We didn't leave enough space for a name because all the names so far were short. But Michael's not a long name. We've just been using shorter names so far. Little debugging, working out little issues like that. That's, y'all know how to, y'all can address that. But notice how, well, we've seen two ways now to organize our data so that we don't have to keep entering it every time. That's a big deal. You'll probably want to start doing that on all of your programs. Even small ones that you're not going to, wouldn't normally save data on. Think about saving your test cases for while you're debugging it. That way you don't have to keep inputting that same data over and over and over again. You can just put your test case in a text file and read that in, so you don't have to keep inputting the same thing over and over and over again while you track down those bugs, because you probably noticed how many runs that actually takes in the program. Right? It takes a few runs. We've got to get this stuff going. But does the basic idea there make sense? So we're writing files just like we saw last week. But we can write special files. I will send out a link to the last time I did SQLite tables, because that's another one we have in Python. I'll just point at this real quick before we wrap up, because it will take a moment. So built into the Python programming language, we have something called SQLite, SQLite, however you want to say it. And this is a small relational database. So here on their website, it says what they have. A small, fast, self-contained, highly reliable, fully featured SQL database engine. Exactly what we want for keeping track of data. It's small, it's fast, has every feature that we would expect in a relational database. Everything Google does, or if you want to make an app for a Google device, it already has SQLite built into it. So it's very, very commonly used. It's in the Python programming language. Everything done in Python has SQLite built into it. And one of the nicest things, so not just the stuff we want the database to be, it's not a full like server database. You wouldn't run your entire industry off this. It's for a program for program. Each program gets its own small database that's enough for that program, as opposed to like the servers Humana runs for all their data. Just enough for that one piece of software. It's stable, cross-platform, so we don't have to worry about somebody wants to run it on a Mac and it was written on a Windows. It was cross-platform. It's backward compatible, and everybody that works on it pledges that it's going to stay that way up through 2050. And 2050 is not when it ends. 2050 is when they're going to reevaluate if that needs to go on. So right now we've got almost 30 years that we're guaranteed that this is going to work. So SQLite, it's working with a relational database. Not everybody in here would have seen relational databases, right? I think some of y'all are in your first semester, so you probably haven't seen relational databases. After class, I will pull up a video from a video lecture I have, and I will send out the link in an announcement so that you can just watch it from that. It was from the same class. Well, I have several of them. I can pull up the video from the same class last spring, or the same class last fall, or the same class the fall before that, because I didn't teach it that spring, or the spring before that, or the fall before that. So I'll pull up one of those videos and send you that, because it's kind of covering the same thing. We just drifted a little further away. Always trying different things, because I think last time I taught this class, it was almost purely the syntax. And well, aside from being boring, we never really saw a full program put together. And that's what this class is, right? Software development. We're not looking at Python syntax. That would be an entirely different label for the class. This class is software development, so I wanted to try using it more with in context. Is this getting extra confusing and stuff, seeing it in context, or would you rather see it in just the syntax examples? So I would like to hear that answer, and then I'll probably continue mixing them so that we see the context where it goes, but I'll change it up a little. One other thing I want to do on this, if I go open the CSV file, we'll see why. Name and rate of pay, that's easy to track here, but usually we'll have more than 2 data points, right? 2 data points isn't much. We're talking about employees, we're gonna have active birthday, number of dependents, names, all those dependents, requests for days off. We'll have a lot of that. So labels go a long way in that CSV file. So to make a label, I'm going to move this declaration up here before our loop. So right before we loop, we'll go ahead and create the writer up here. And then our first row, writer dot write row, just to review the important part. That kind of went off in a little tangent there. When we get it back, and the important part, remember how much simpler this one was than that sequential text file? We just get that writer, and everything's built in. It's like one line, and then we ask for the next item. So let's add some labels in here. And it's CSV, so we have to make it an array, so square brackets. I'll make the first element in the array just the label for name, and the second one rate of pay. And then we'll go in here and do that easy part. So there was a little bit of distraction, so you might have forgotten how much easier that writing to the CSV file was than the sequential file. That's the important one, because it's easier to write and keeps our data highly, highly organized. Much easier to work with. So now I'll get rid of this old one. Well, labels might be a problem there because we're gonna have pans, so it'll keep putting new labels on. So I'm gonna hit undo and not do that. But that's how you would do that. Undo, 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 undo. There we go. So back to that easy one, because we can keep track of it in this case. You all can figure out the label thing later. If you've seen it once, it'll be in the back of your mind when you need to stop and figure it out. But hopefully that looks a whole lot easier. It's a much better way to keep track of our data than sequential text files. I'll just undo that now. Does anybody have any questions about those? Stop the screen share so I can see your. Okay, if there's no questions, that'll be it for this evening. Looks like there's only 20 minutes left on our time. I intended to stop about 8:20 and actually had something else I wanted to cover, so I was way off judging the time again tonight. That happens. I will send out a video for using SQLite. So there's even more ways to do this. We can also use JSON. Okay. Yeah, so it's on the Zoom and all the lectures are recording. Oh, I did put the link to the playlist for where I do long-term storage of videos. I use YouTube for long-term video storage because they're big files and they'll just burn up a lot of space on the hard drive. I put that link on the homepage on Ivy Learn. I guess I could point at that. If you go to Ivy Learn, amongst those links there that are kind of useful, click through a bunch of things, and this is our class with the Babbage engine. Yeah, so I went ahead and put the link to the YouTube playlist where I store the videos long term. If you want to find them there, because they're also available in the Zoom one, but Zoom has strange recordings. YouTube are strange controls. YouTube has normal controls, right? That's what we're used to a video, how we're used to interacting with a video. So personally, I'd rather watch it on YouTube than Zoom because that's the controls I'm used to for watching video. I'll also download those notes from the board. I think I'll probably try something different next time. I haven't quite figured out what to do on the smart board, but it's gonna take a couple tries to figure that out, figure out what works on that. It's a little smaller than the big board, but it's digital, so it has a lot of advantages too. But I'll download that PDF and put it on GitHub. That stuff will be on GitHub. It's been a few seconds. Any questions? Okay, I assume no questions. Think about that question I asked about preference. Would you rather see in the situation where we're building the software or the syntax? Because we're going to see both, but I'm not sure which one to show more of. Right? If that makes sense. I don't know how to mix. I don't know what a good mixture is. So if you have a preference, let me know, and I will adjust whether we see more syntax and less full example or more full example and less syntax time. But there will be some of both. Otherwise, that'll be it for tonight. I will see you all on Wednesday. If you have any questions, let me know. I'm always happy to help. And if you want to stick around for a minute and look at that thing you were having trouble with, Joseph, we can look at it after the Zoom call. Otherwise, I'll see you all Wednesday. Everybody have a good one. Here.